Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Farhan from 2E class Polytechnic Negeri Sriwijaya, the major of Electronica. Today, in my presentation, I would like to present about electronic speed control. The body paragraph in this matter. The first is about the definition of ESC. The second is battery eliminator circuit. The third is classification of ESC. The fourth is remote control application in ESC. And the last is the firmware of ESC. Okay, let's start from the first slide. What is ESC? Electronic speed control, or ESC, is an electronic circuit that controls and regulates the speed of an electronic motor. It can also provide motor reversal and dynamic braking. The miniature electronic speed control is used in electrically controlled radio control models. Full-size electric vehicles also have systems to control the speed of their motors. The basic function of ESC is to change the amount of power to the electric motor from the aircraft battery based on the location of the throttle stick. Electronic speed control follows the speed reference signal derived from the throttle lever, joystick, or other manual input, and varies the switching rate of the field effect transistor, or FET network. By adjusting the work cycle or switching frequency to the transistor, the motor speed is changed. And then, for its location on the airplane, the ESC is plugged into the throttle line at the receiver and connected between the motor and the battery pack. Okay, next is about BEC, or battery eliminator circuit. In electrically controlled radio control models, BEC, or battery eliminator circuit, is usually part of electronic speed control, or ESC. The battery eliminator circuit is a feature built into the ESC that allows the ESC to provide electrical power to both the motor and receiver with the same battery. When the voltage is too low, the BEC circuit cuts off power to the motor but still provides power to the receiver, which allows the receiver to operate properly so that the pilot can land the plane safely. BEC also comes in several forms. The first is SBEC, or switching battery eliminator circuit, and the second is UBEC, or ultimate battery eliminator circuit, being the main varieties. For the next is about classification of ESC. ESC is usually rated according to the maximum current. For example, 25 amperes or 25A. Generally, the higher the rating, the greater and heavier the AC tends to be a factor when calculating mass and balance in an aircraft. Many modern ESC support nickel metal hydride, lithium-ion polymers, and lithium iron phosphate batteries with a series of input voltage and limits. The type of battery and the number of cells connected are important considerations when using a battery elimination circuit. Whether installed on the controller or as a standalone unit. The higher number of cells connected will result in a reduced power rating and hence the lower number of servers supported by integrated BEC if using a linear voltage regulator. A well-designed BEC using a switching regulator may not have the same restriction. Fourthly, is about remote control application in ESC. In operating the remote control application, ESC can be a standalone wheel that is connected to the receiver throttle control channel or inserted into the receiver itself, as is the case in most toy-level R or C vehicles. ESC designed for radio control aircraft usually contain several safety features. If the power coming from the battery is not enough to continue running the electric motor, ESC will reduce or disconnect power to the motor while allowing the use of the ailerons, steering, and elevator function continuously. This allows the pilot to maintain control of the aircraft or fly with low power to safety. And then, ESC designed for radio control helicopters do not require braking features because one-way bearings will make it useless at all costs or require reverse direction. Although this can be helpful because motor cables are often difficult to access and change once they are attacked. Many sophisticated ESC helicopters provide governor model, which fix the motor RPM to a specific speed, greatly helping CCPM-based flight. It is also used in quadcopters. Okay, for the last is about firmware of ESC. Most modern ESC contains microcontrollers that translate input signal and control the motor precisely using the default program or firmware. In some cases, it is possible to change the factory default firmware to an alternative, publicly available open source firmware. This is done in general to adopt ESC to certain applications. Some ESC are manufactured by manufacturers with firmware capabilities that can be upgraded by the user. Others require solder to connect programmers. ESC is usually sold as a black box with proprietary firmware. In 2014, a Swedish engineer named Benjamin Fieder started the open source ESC project, which was later called VESC. The VESC project has since attracted attention for advanced customization options and relatively reasonable building price compared to other high-end ESCs. Okay, I think that's all in my presentation today. I'm sorry if I make a mistake. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.